This video is on the objective solve applied problems with the law of sines. So word problems, and I notice in most of these they're going to be basically drawing a picture of a triangle for you. In some of them you may have to draw a triangle yourself, and then hopefully you're given enough information to where you're in the ASA or AAS or SSA cases. In each of those cases, right, you can apply the law of sines to help you solve the triangle, find some missing piece of the triangle. Alright, so again, if you want to see more about the topic, click on More Instruction, look at their videos, their notes, their examples, and hopefully those help you out. Now this is similar to the first video. For some reason there's another question here about artillery bases, right? But still, they're giving us a nice picture of a triangle and asking us to find some missing piece. Alright, so two artillery bases are located at points A and C below. Each of the bases locates an enemy plane at point B and measures the angles of elevation to that plane. So from base A, they have to look up 77 degrees to see the plane. From base C, they have to look up 82 degrees, tilt their head up 82 degrees to see the plane at that same spot. So given the elevation angles in the figure and the fact that the two bases are 743 meters apart, what is the distance in meters from the base at point C to the airplane? Alright, so again, I'll draw this on a piece of paper here. So I have a triangle like this, right? So point B is where the plane is. There's a base at point C, a base at point A. And remember, the opposite sides would have, little c for opposite angle C, little a opposite angle A, and little b opposite angle B. And we're told the distance between A and C is 743 meters. Angle C, right, the angle of elevation to look up at the plane at that point was 82 degrees. And the angle of elevation here at A to look up at the plane at that point was 77 degrees. So what I have here is the angle side angle case. Alright, the angle side angle case. Two angles and the side between them, the side that they share. And in the angle side angle case, right, we can apply the law of sines to help us find missing pieces. Now the first piece is the easiest. Angle B is the easiest to find. Because once you know two angles of a triangle, you know the third one. Right, remember, all three angles have to add up to 180 degrees. So angle B is just going to be 180 degrees, minus these other two, minus angle A, minus angle C. Right. Now 77 and 82 make 159. So angle B needs to be 21 degrees to make 180. Right. But that's not what's being asked for. Right. I'm only putting in angle B because I'm going to need it when I use the law of sines. Right. They're asking for this value. Right. They want side A here, the distance from base C to this plane in the sky at that point. Alright, well, I know angle B, I know side B, and I know angle A. I'm just trying to find side A. So side A. So I'm going to use the law of sines here. It's the angle side angle case. I can apply the law of sines. Or I'm gonna do that version where it's flipped and the side lengths are in the numerator. When I'm trying to find a side length, I'll have the version with the side lengths in the numerator. When I'm trying to find an angle measure, I'll do the version where the sines of the angles are in the numerators. So we have a little a divided by the sine of angle A, so the sine of 77 degrees. That ratio should be equal to the same ratio for any other side and angle, right? As long as they're opposite each other. And I'll use the B stuff, right? I know both pieces of B information. So in the numerator, the length of side B, 743 meters, divided by the sine of angle B, which we found was 21 degrees. And then to get side A alone, all I would need to do is multiply by the sine of 77 degrees. So A is 743 times the sine of 77 degrees, and then that was over the sine of 21 degrees. And then here, this is perfect. This is the exact measure of the length of side A. But, looks like from all my answer choices here that they're rounding to 1 decimal place. They're rounding to the nearest tenth. So I'm going to punch this into my calculator. I got the calculator up. Make sure you're in, my angles are in degree measure here. I'm going to make sure I'm in degree mode first, which I am. 743 times the sine of 77 degrees divided by the sine of 21 degrees. And so the side length A, the distance from this base at point C to the plane at point B, is approximately 2020.1 meters. And that's all we're asked to figure out using the law of sines. And it looks like this first option, 2020.1. Great. And again, they take you through the same calculations I just went through. Great. I'm hoping that watching me work over this, looking at the more instruction when you need to, and reading the answer explanations when they come up. I'm hoping all this stuff helps you, when you're working on this material on your own. And thank you for watching.